Now in complex analysis, we'll be looking at Cauchy-Riemann equations. Before that, please like, share and subscribe this particular channel and click on bell icon to get a new notification. Let us start now. Complex analytic functions. Okay. Before going to the complex analytic function, first you have to understand about the complex variable function. For this one, if you consider a complex number like z is equal to x plus iy. Okay. And if you consider f of z is equal to z square, then it is equal to nothing but x plus iy whole square, right? If you expand it, we get as x square minus y square plus I into 2xy. As I know, as I square is nothing but minus 1, so we get a minus here also. So it is nothing but f of z. Now what we do is nothing but divide the real and imaginary. If you consider u of x comma y as an x square minus y square, and v of x comma y is equal to 2xy. It's an real, right? And this is nothing but imaginary. So when you write it, it gets as u of x comma y plus I times of v of x comma y, which is nothing but f of z. Now f of z is called as a complex variable function. As we can see that u and v are nothing but functions of x and y. So f of z is nothing but called as a complex variable function. Now if you consider a complex analytic function, okay, it's nothing but a function, variable function f of z is said to be an analytic function. It's nothing but the first condition is nothing but it should be a continuous function, okay, function. Then the other condition is nothing but f dash of n z exists. Then that particular function is known as an analytic function. Now I'll be explaining you by means of a definition, okay. Now we'll be looking at the conditions of a complex analytic function, okay. As nothing but the necessary and sufficient conditions of a complex value function f of z is equal to u x comma y and I v of x comma y is said to be an analytic in a region R if given a function, right, and it's a u plus iv format, and u is a function of xy and v is a function of x comma y. Now the first condition is differentiation of u and v with respect to x and y should exist, and it should be continuous on a region R. Come next one. When you differentiate u with respect to x, it should be equal to differentiation of v with respect to y, and differentiation of u with respect to y should be equal to minus of differentiation of v with respect to x. These conditions are called as a CR equation, okay, or Cauchy-Riemann equation, where we know that u is nothing but real part of f of z and v is an imaginary part of f of z. Now in the case of a polar coordinates function, okay, that is nothing but f of z is equal to u of r theta plus iv r theta format. Then the Cauchy-Riemann equation is given as nothing but du by dr should be equal to 1 by r into differentiation of v with respect to theta, and differentiation of v with respect to r should be equal to minus of 1 by r into differentiation of u with respect to theta. This is a condition. It should be satisfied. Say that it is an analytic function or not. Okay. Now coming to the question. The question is if z is equal to x plus iy, then find if z square is analytic or not. Okay. So they given the function f of z, which is equal to z square. So which is equal to nothing but x plus iy whole square. So when you expand it, it becomes x square minus y square plus I 2xy, right? As you know, I square is minus 1, so yeah, minus comes here, right? Now we have to see this particular function is analytic or not. First, what to do is to not find the real and imaginary. This is an real, and this is an imaginary. So this is nothing but u, and this is nothing but an v. So we got an u and v value. U is equal to nothing but x square minus y square, and v is equal to nothing but 2xy, right? Now the condition, we know that CR equation condition is nothing but differentiation of u with respect to x should be equal to differentiation of v with respect to y. Another condition is differentiation of u with respect to y should be equal to minus of differentiation of v with respect to x, right? Now let us go with this first one. When you differentiate u with respect to x, the u is given here, so it becomes 2x, which should be equal to v with respect to y, which is equal to 2x, right? I can see that v is equal to xy, right? Come to the next one. When you differentiate u with respect to y, so it becomes minus 2y, right? Now differentiate v with respect to x, so which is equal to minus 2y, right? Now you can see that 2x is equal to x got satisfied, and minus 2y is equal to minus 2y got satisfied. Both of them got satisfied, and differentiation also of a u and v with respect to x and y is also got satisfied. So we can say that f of z, which is equal to z square, is nothing but an analytic function. Okay. Now coming to the next question. The question is, if f of z is equal to x square plus ay square plus ibxy is a complex analytic function of z is equal to x plus iy, then a is dash and b is dash. So we have to find the value of a and b. Now this particular f of z is analytic function they are given. So they given that f of z is equal to x square plus ay square plus I bxy, right? Now we'll be finding the u and v values. See, the real part is this in the real part, and this is an imaginary part, right? So it is a real part, so this is one nothing but u, and this is an v value. So we got an u value is equal to nothing but x square plus a y square, and v is equal to nothing but bxy. Now they are given that the function is an analytic function, right? When you differentiate u with respect to x should be equal to differentiation of v with respect to y. Another one is nothing but when you differentiate u with respect to y should be equal to minus of differentiation of v with respect to x. That's the condition, right? Now we'll be differentiating u and v. When you differentiate with an x, the u value, it becomes 2x is equal to, when you differentiate v with respect to y, it becomes bx. So here x's get cancelled, and we got a b value is equal to 2. Now coming to the other one. That's nothing but when you differentiate u with respect to y, then it becomes nothing but this one becomes 2ay, right? Should be equal to, we differentiate with an x, so it becomes minus b, right? Y by get cancelled here, and we know that b is equal to 2, so it becomes 2a is equal to minus 2, which implies a is equal to nothing but minus 1, right? So we got an a and b value is nothing but minus 1 and b is 2. I'm going to say you the important definitions and important points of a complex analytic function. Okay, the first one is nothing but a complex value function f of z is said to be analytic in a domain or in a region R if f dash of z exists at every point of an R or a region. Okay, f dash of z should exist at every point of an R, then it is known as an analytic function. Okay, one more point you have to remember is a complex valued function f of z is analytic in entire complex plane, then it is called as an entire function. Okay, now come to the next one. If f of z is analytic at point z0, then the derivative f dash of z is continuous at z0. Okay, by reading all this point, you have to remember only 2 points. It's nothing but it should be in a continuous. Okay, and second one, f dash of z should exist. Right. Now, by using some methods, we can find whether the function is an analytic function or not. Let us see on it.